Well, back again with the same model and same neural network we have built in our last lecture. Let's improve it. Let's improve our model. How can we improve it? Let's create a new model. Let's create a new model using the same code so that we can compare actually. We are taking codes only till compile because this is the base things. So let us check what can be the problem. How can we improve? Number one, we can try increasing the number of neurons in our layers, in our input layers. We can say 50. Number two, we can change our optimizer. We can say Adam, which is best so far till today. And then execute it, compile it, then fit our model or train our model. X, Y, and epochs equal to 10. We don't see any improve, rather we see it has gone so far. If we look at our previous model, we see the loss is 13.31 and error matrix is 13.31, but here it's so high, 27.5. So we can try increasing the number of epochs. The number of epochs actually help us to train the number of times. So we will try to train 50 times. We can see we have improved a lot. Seriously? So let's try to predict. Let's pass 23 and we should get near about 33. And we're getting 29, which is so close in comparison to our previous models. But still we are so far. So is there any way to improve our model? Yes, there is. First of all, we can increase, actually we cannot increase, we can add learning rates, because till now we have not added any learning rate. We can actually create a variable and name the variable according to the optimizer name, Adam. And here we can say tf.keras dot optimizers dot Adam, and inside constructor argument we can say learning rate and pass one learning rate 0.001. And then here instead of a string we can just pass our variable and compile it and train it. But after defining the learning rate, we see some changes. That's very good, but the loss and error rate is very high. Let's try to predict, and we can see the far more difference. What can we do? Let's try increasing number of epochs. And this time it has performed very well. So let's try to predict the value, and we can see 29, but it's still so far. So what can we do to improve our model? Till now we have not used any activation function, so let's try one activation function. Activation, and here we can use softmax Okay, forget to add the comma. Execute it again and train it again. And we see some worst perform. What about ReLU? The best activation function so far, we can say ReLU, and for our output layer we can say activation linear. Okay, forgot one comma. Execute it and execute it. And we found a little bit improvement. Well, at this stage, don't think that I don't know about all these steps, and that's why I'm getting here. I'm experiencing this here with you so that you can understand how it works actually. What is the difference of all this? The machine learning and deep learning is all about experiencing and experiencing. So let's go back to our code. And here, let's increase the learning rate. Execute it again. Repeat again. And this time we can see a little bit difference, a little bit improvement. So let's try to predict. And really it has improved a little bit. We expected 33, but it has predicted 30. What are the areas we can improve? So let's check it. Our dense layer with 50 neurons, output layer with 1 neuron, optimizer Adam with learning rate 0.01, matrix MAE, loss function MAE, number of epochs 100. So we can do two things. First of all, we can increase the number of epochs, the number of trainings. We can make it 150. Execute it and execute it. And we can see a great improvement. We have only 1.4 loss and 1.4 error matrix. Let's try to predict. And we can see we have improved a little bit. What about we use 200 epochs? Okay, by mistake I have not initialized. The model, so I just retained the model. So now it has trained for 400 times. But that's okay, we can just predict it. And we see we have predicted perfectly. It's very close and very good prediction. So here we can try with 300 first and then again try with 400. Execute this one and train again. And we can see we have improved a lot. So let's predict again. And we can see we are very close. So if we try training with 300 epochs, then we will get a better result. What if we decrease the number of neurons? Because we have only 20 data, but we are passing 50 neurons. So we can pass 20 neurons here, execute it, and train it again. and we can see the change in the prediction. So now, what if we have a large set of data? Let's say we have 100 data instead of 10 data. Let's try that in our next lecture.